Okay, hi everyone. Welcome back to Concordia University's fourth space. Thanks for joining us. If you're just joining us now, today is very much Space Day, which is really a chance to see behind the scenes of Space Concordia's many divisions and some of the projects that they're working on. But we'd like to begin by acknowledging that Concordia University is located on unceded Indigenous lands here in Tiohtià:ke, Montreal. And we do respect the continued connections with the past, present, and future, and our ongoing relationships with Indigenous and other peoples within the Montreal community. Here at ForSpace, we work with our university community to help mobilize knowledge. We co-create daily activities examining research questions and projects, things happening all across the university. We're running today's event as a live stream Zoom meeting. We're live streaming to YouTube as well. Those of you joining us on Zoom, pop your questions into the chat. We'll read them out. Those of you here in the space, we're going to have a little Q&A later on, and we'll run microphones around so that everyone can hear. Okay, that's enough for me. It's now very much my pleasure to hand the microphone over to our Director General, Space Utilization at the Canadian Space Agency, Guennadi Kroupnik. Welcome in.
Good afternoon. It's a great pleasure for me to be here today, back to my alma mater. And speaking frankly, I feel a lot of envy to you guys because it was never a better time to enter space enterprise in Canada. And hopefully I will make my case why. Because in addition to massive, unprecedented investments by Government of Canada in space capabilities, both on civilian side and defense side, we have a very vibrant research community in universities, as well as very dynamic industrial sector represented by what we would call traditional companies like Telesat Canada, MDA, and a growing number of new space companies like Kepler, Reaction Dynamics, Wyvern, North Space, and many others who are creating more and more opportunities for students, internships, and eventual work. So I would like to start with great history of Canada in space and a strong legacy of innovation that we all could be very proud of. It all started in 1960s with Alouette, which made Canada the third country in the world after Soviet Union and United States to build and operate its own satellite. It continued in 1970s with Canada pioneering satellite communication with Telesat Canada and Onyx series of satellites, providing first truly national television broadcasting across entire country, coast to coast to coast. In 1980s, emblematic Canadarm1 on space shuttle opened an era of space robotics. In 1990s, we have launched our first in a family of RadarSat synthetic aperture radar satellites capable to see at any meteorological conditions, day and night. And in 2000, we joined the privileged club of a few nations building and exploiting International Space Station. That legacy of innovation continues. Based on strengths in Canadian space enterprise at the Canadian Space Agency, all of our activities are grouped around three programs. The first one, space exploration, which basically is using a vantage point of space to peer in the universe away from Earth to study laws of physics, origins of universe through astronomy, planetary science, going to the moon, Mars, and beyond. Another program which I have a pleasure to lead, Space Utilization, is doing directly opposite. We are using vantage point of space to look back at Earth, to provide valuable and indispensable services to Canada, Canadians, and global community. And a third program, Space Science and Technology and Capacity Building, serves space exploration and space utilization by developing cutting-edge technologies and maturing science required to realize space utilization and space exploration missions. Of course, I will focus on space utilization. And in space utilization, we have a number of pillars. So number one is satellite Earth observation. Number two, satellite communications. And what used to be previously called GNSS, Global Navigation Space Systems, now is rather called PNT, which is positioning, navigation, and timing. An example of that is GPS in US or Galileo and a number of other systems, without which it's very difficult today to imagine our day-to-day life. And the last but not the least area of our activity is space situational awareness and space traffic management. So let me talk a little bit about each of them. The biggest investment so far Canada made in Earth observation. And that is not surprising, taking into consideration that we have the second largest landmass in the world and the longest coastline with a very low density of population, observing, monitoring, and securing that vast landmass is only possible by using space and space technologies. So the role of satellite Earth observation is to provide data and that data to be transformed into information products to facilitate decision-making on a wide range of issues, starting with sovereignty, security, climate adaptation, exploitation and exploration of natural resources, and many others. What are the current trends? If even a few years ago, satellite Earth observation was predominantly area of institutional players, mostly government agencies. Over the last 10 years, a large number of commercial entities found an innovative business models allowing them to enter this domain. And you can think about Planet, for example, and a number of others who are very successful in the domain of Earth observation. There is a growing demand for, I would add to what you see on the slide, in a current changing geopolitical situation, to sovereignty and security information, but as well environmental and industrial intelligence. Of course, today, growth of artificial intelligence and machine learning opening very new opportunities for Earth observation and transforming acquired imaging and data into information products supporting important decisions. The flagship of the Canadian Earth observation RadarSat family of satellites RadarSat-1 was launched in 1995, and we are currently flying and operating the third generation of RadarSat family, RadarSat Constellation, which is a constellation of 3 satellites capable to image entire Canadian landmass and maritime approaches in one day, and imaging vulnerable areas in the Arctic 4 times per day, which is extremely important. And we have an opportunity to see 90% of the globe in every day. Exploiting benefits of RadarSat Constellation, over a dozen of Government of Canada departments delivers more than 40 critical services to Canada and Canadians. This is why continuity of supply of this data and services is very important, and we are currently working on a so-called replenishment satellite, which would be addition of the 4th satellite to the constellation, not identical to the previous 3, with an objective to enhance resilience and longevity of the constellation. And meanwhile, we are working on a next generation, which will be a system of systems combining synthetic aperture radar in different spectrum frequencies, C, X, and L, as well as high-resolution optical data and other cutting-edge technologies. As well, we are in a process of delivering a HAWK, which is high-altitude water and clouds Canadian atmospheric science mission, studying very important processes in atmosphere linked to a changing climate and helping us to improve climate and weather modeling, most importantly, allowing us to better forecast severe weather events and to protect lives and property by doing that. HAWK is 3 Canadian science instruments which have been envisioned by a consortium of 14 universities, 2 of them here in Montreal, McGill and University of Montreal, plus 12 another universities across Canada. Those instruments are Ali, Show, and TICFIRE. Ali and Show will fly on a standalone Canadian satellite, and TICFIRE will fly on a NASA satellite, because HAWK is a Canadian contribution to a much larger international undertaking called Atmosphere Observing System, led by NASA with participation of Canada, Japan, Italy, and France. Also, there is no day or time in the day when you will look at the news and they would not talk about wildfires in Canada. In 2023, we had the worst wildfire season in Canada, but 2025 already exceeds the damage caused by wildfires in 2023. There are many contributing conditions to that, and this is why the government of Canada invested significant funds in developing a constellation of 7 microsatellites with 2 hot spares in space to monitor wildfires in Canada. The constellation will be launched not later than fire season of 2029, and it will allow firefighters in Canada to have much better information on fire behavior, allowing them to allocate resources where they are mostly needed. In addition to what we have in our fleet now and what we are working to launch in the nearest future, as you might know, space mission takes a long time to prepare, develop critical technologies and mature science. This is why we're working on a number of other very important space missions addressing priorities of Canada and Canadians. One of them is terrestrial snow mass mission, TSMM. Living in Canada, we are all used to snow being omnipresent, but there is a very important problem, very difficult to solve. It's to calculate water content in snow. And water content in snow is extremely important for a number of applications, like, for example, accurate forecasting of floods or power generations by hydro. As well, we were just talking a minute ago about wildfires. The water content in snow helps to predict how severe a coming wildfire season will be. If that mission will be funded by the government of Canada, it will be the first in the world KU double frequency synthetic aperture radar satellite deploying that cutting edge technology. Another very important mission that we are working on currently is, I like to call it the most Canadian space mission we can have, is Arctic observing mission. You might know that there is a gap of coverage of the polar areas by geostationary meteorological satellites, and polar orbiting meteorological satellites do not provide timely resolution sufficient enough for accurate weather prediction. With changes in geopolitical situation and threats to Arctic security, sovereignty, and safety, weather forecasting in the Arctic becomes extremely important. This mission will see 2 Canadian satellites flying in unusual, highly elliptic orbit, which will create quasi-geostationary conditions, basically satellites hanging over Arctic for a vast majority of time in orbit. So the satellites will zoom very quickly over South Pole and then hang for a long time over the Arctic, providing excellent conditions for observing Arctic with basically same time resolution of 15 minutes as geostationary satellites provide in mid-latitude. And another interesting undertakings that we are working on at this point in time, to get maximum out of Earth observation takes several important elements. Of course, more and more sophisticated data with higher resolution, with richer content due to the different use of electromagnetic spectrum is important. But sophisticated IT infrastructure, as well as tools to transform and merge data into information products enabled by AI and machine learning is as important and maybe even more important than just additional source of the data. So this is why we are working on DEC, which is Digital Earth Canada, which is an exploitation platform which brings together modern computing power, vast trove of data that we have in Canada, as well as sophisticated tools to fuse and process data to come up with more and more accurate and validated, ready for decision information. Very quickly, I will cover other pillars of space utilization, starting with SATCOM. From 2012, Government of Canada focused more on technology development in this domain than public investments in government-owned and operated system. The last satellite communication endeavor by Government of Canada was KA, first in the world, KA band communication broadband payload on Telesat's Anik F2 at the beginning of the 2000s. Since that, our focus was on technology development, and it produced very good results. For example, a new space company, Kepler, is leading the world in optical communication, and it's the first time Canadian Space Agency is a member, the only one non-European member of European Space Agency. And Kepler is the first Canadian company to play a role of a prime contractor on ESA procurement for Hydron DS, which is high throughput optical network demonstration system, which will see a ring of 10 satellites with optical inter-satellite links, demonstrating transmission of signal from a third party's clients and using inter-satellite link and optical high throughput downlink to Kepler's ground stations. But also, I would like to bring to your attention an example of Telesat and MDA, who are currently building right here in Montreal on West Island, Lightspeed constellation. You probably all know SpaceX's Starlink constellation of communication satellites. So Lightspeed will be a constellation of close to 200 low Earth orbit satellite cross-linked, which are more sophisticated than Starlink satellite, will provide a higher level of security and will have some features which are very important in the current world, especially using artificial intelligence and machine learning for communication traffic management, as well as optimize allocation of communication frequencies. Speaking about satellite navigation, rather I would say PNT, which is positioning, navigation, and timing. Everyone knows about positioning and navigation. Everyone uses one or another navigator moving around, and it's very convenient. But I would like to bring to your attention the importance of timing. For example, in a modern world, none of the financial transactions can happen without precise time stamp, because otherwise the whole financial system will be screwed up if we do not have that sequential order managed by the timestamp. And it's only one of the examples why PNT is so important. And again, due to the geopolitical context and operations in the denied environment, which means operations where access to normal PNT services like GPS is denied by jamming or spoofing. It requires innovative and new ways to ensure that the government of Canada and Canadians have access, uninterrupted access to those critically important for our day-to-day life services. And as a recent successes, I would like to bring an innovative idea of a company called Zona. This company was kicked off by PhD graduates from Stanford University, and it has a direct connection to Montreal because one of the founder of the company is a Montrealer, and they have a facility here in Montreal, which they are planning to develop into operation center and manufacturing facility for LEO PNT network with very innovative technologies underlying it. The last thing I wanted to talk today to you, and the last pillar of space utilization activities at Canadian Space Agency, is space situational awareness and space traffic management. Space situational awareness with all the mega constellations being launched and all the space debris flying around Earth in most needed orbits, there is a growing concern that unless we will be able to monitor all the objects in space and will be able to assess probabilities of collision and avoidance maneuvers, we might see a situation where some of the low Earth orbits will become unusable. And there are even catastrophic scenarios where a chain reaction of the collisions, as you have seen in the movie Gravity, might cause layers of orbits unusable, which will have very significant consequences for us on Earth. So this is why space situational awareness is very important, and space situational awareness has elements of observing what's happening in space, and it's done both from space and from the ground. From space, we are operating Canadian, what we call Humboldt telescope, NEOSat. It's a suitcase size satellite with a quite powerful payload, which allows us to observe orbits in LEO and from LEO up to cislunar orbit. As well, Department of National Defense operates a Sapphire satellite, which contributes to the allied network of observing sensors to understand what's happening in space. As well, in Canada, we have a number of optical telescopes and radars with an objective to collect information on debris and other objects in important for us orbits. But having information and reliable information is just a part of a problem. Then we need to do something about it. And we have developed at the Canadian Space Agency CRAMS, which is Conjunction Risk Assessment and Mitigation Tool, which identify potential collisions and calculates maneuvers for satellites which do have propulsion. Mostly it applies to our RadarSat family of satellites to perform avoidance maneuvers in critical situations. And the last one, we are operating Canadian Satellite Operations Center, which basically represents a main operation center in Saint-Hubert and a backup facility in David, Florida laboratory in Ottawa. It includes 3 civilian ground stations with large antennas for command, telemetry, and downlink of the data in Gatineau, in Prince Albert, in Albert, and in Inuvik, as well as not showing on the slide 2 ground stations operated by the Department of National Defense on Atlantic and Pacific coasts. And I would like to finish with this slide, which demonstrates a number of satellites Canada either developed and operates or contributed to, and different altitude not necessarily reflects correctly altitude. It's the lowest layer. It's a strictly Canadian satellites owned and operated by Government of Canada, whereas above you can see all the international missions with a significant contribution by Canada and Canadians. And you can follow us on the web and media. And on that, I will stop. And if you have any questions, we'll be happy to answer.
Does anyone in the audience have any questions? If you do, raise your hand. I'll get this microphone to you. Okay, it looks like
I promise I will not bite.
I think we're going to go ahead and just say thank you again, and we'll maybe have an in-person Q&A for those who are maybe a little shy. So thank you to those who have joined us online. Oh, we have a question actually online, just in the nick of time.
So this question from Gutham is, how are we going to launch all these satellites and from where?
It's an excellent question, because up to now, in Canada, we do not have launch capabilities. So all of our satellites were launched in partnership with other countries, most from US. By the way, Canadian Cassiope satellite was the first commercial payload ever launched by SpaceX Falcon 9 in 2013. RCM also, RadarSat Constellation mission, was also launched by SpaceX Falcon 9. But we had a very productive partnerships with India. And for example, NeoSat, Sapphire, M3MSat were launched by Indian PSLV rocket very successfully. Nevertheless, again, in a changing geopolitical environment, we have an opportunity and need to develop Canadian launching capabilities. We probably will never develop something like Starship, but to launch small and medium-sized satellites, we have a number of Canadian companies. One of them, Reaction Dynamic, right here in Montreal, founded or co-founded by Concordia alumni, who are thinking and working very hard on developing launching capabilities in Canada. So Reaction Dynamic recently went into a deal with Maritime Launch Services, a company which develops a spaceport in Nova Scotia, where they secured launch pad for their future missions. As well, you will probably have seen in the news last week, Nord Space, another Canadian company, tried to launch their first suborbital rocket. They have a couple of glitches and had to postpone that launch, but there is very active and dynamic context in Canada, and the need is obvious. Canada can benefit from its geography because we can greatly launch both in polar, inclined, and geostationary orbit. We are excellent places for spaceports to launch in polar orbits. So I hope that one day we'll see Canadian capabilities and Canadian satellites being launched by Canadian rockets. Go ahead.
Okay, so with the increase in popularity of like lunar operations, what steps or what kind of position do you think Canada should take in kind of securing lunar, like the space around the moon, kind of preventing this kind of low Earth orbit debris field that we have here now, this problem developing here on Earth?
Yeah. I'm not sure I fully understood the question. The sound is not great, but I'll try to answer. First of all, speaking about lunar orbit, there are many challenges with lunar orbit, and Canada is part of a gateway undertaking, an Artemis Accord, bringing together a number of countries to go to the moon and stay on the moon, to build a permanent presence on the moon. It will require communication capabilities, which will allow us to communicate with the people on the surface on the moon, and as well orbiting assets around the moon. But can you repeat your question?
Yes, no problem, no problem. So with this low Earth orbit debris crisis or issue that we're having here around Earth, like what steps should Canadian government take to prevent that from happening now around the moon?
Okay, understood. So basically what's happening currently in low Earth orbit mostly, as well as the geostationary orbit. First of all, let's start with geostationary orbit. There are a kind of places for geostationary orbit satellites to be safely stacked, like a cemeteries for the out of date satellites, where they can safely stay practically forever, not interfering with the utility of a geostationary orbit. For lower Earth orbit, the way of disposing the satellites was reorbiting them, deorbiting them, bringing them down and making them burn in the atmosphere. The current rule is that the satellites should go back and deorbit in 25 years after the useful life. 25 years, it's a long time. And this is why there is a push, and some jurisdictions introducing a regulatory environment where they request organizations under their jurisdiction to deorbit in 5 years. However, there is a new challenge, because recently scientists are getting more and more worried with increased number of deorbiting satellites about pollution of the high layers of the atmosphere by heavy metals present in the satellite. So it is an interesting challenge which your generation will have to resolve, what to deal, how to clean the, first of all, low Earth orbit to have a sustainable space utilization. Jan?
You said that currently and in the past destinies and all that, we didn't launch satellites from Canada. Was this mostly a financial decision that we didn't build any launch pads from here, from Canada in the past 30, 40 years? Or was this because if you said that we mostly launch in US, India, other countries, we know that in the US there was a enormous push for space exploration with the Cold War, with the USSR. It was the lack of, competition with another country, maybe the reason why Canada hasn't relied mostly more on other countries than the US, for example.
So there were a lot of financial policy and other consideration why Canada did not focus its investments on launching capabilities. I should say that in 1950s, Canada was developing a Black Brant suborbital rocket and was launching suborbital rockets from Churchill in Manitoba on a regular basis. And kind of step from that suborbital rocket to a launcher was not that big. Nevertheless, Canada made a decision to focus on Earth observation, SATCOM, PNT, and the geopolitical context kind of supported it in a sense that there were large number of available launchers provided by different countries. So we were not that much dependent on one launch provider. With significant changes in the geopolitical situation, it all changes, and having sovereign capability that we can rely upon becomes very important. And I believe we will see a change in investment strategies, which will lead to development of Canadian sovereign launch capabilities.
Great. Thank you so much. That's all the time we have for questions. So thank you once again to our speaker. A round of applause, please. And stop the live stream, but we will be back at 1:15 for our next talk. We hope to see you there.